So far for processing framework, we have seen MapReduce, which is also classic. And in the latest version of Hadoop, classic is not the default one. Yarn is the default one. First we need to understand what are the challenges with MRV1 or classic, and how, and then we can talk about how Yarn overcomes that. MRV1 classic is a single point of failure. So if job title goes down, then you cannot submit jobs in the cluster. You can load the data into Hadoop using Hadoop ffs-put commands and all those things, but you cannot run any MapReduce jobs if job tracker goes down in MRV1 classic. Okay, and it is tightly coupled with MapReduce. Okay, so it only works with MapReduce. If you want to run any non-MapReduce tools in the cluster, you cannot use MRV1 classic for that. Also MRV1 classic, while deciding on submitting the jobs, it only keeps track of MapReduce resources used by MapReduce. Okay, but lately there are many tools that do not use MapReduce, like HBase, Spark, and many other tools. They will not use MapReduce. So if you deploy MapReduce based tools and non-MapReduce based tools on the same cluster, and if you are using MRV1 to submit the MapReduce jobs, as it does not keep track of non-MapReduce based tools, it can make bad decisions while submitting the jobs, and it can cause significant issues to the cluster. And also, as we have seen, where is it? So as we have seen, the mappers and reducers are pre-configured. Mappers are configured for as 32, and reducers are configured as 8 in this case. If we run map-only jobs, let's say most of your MapReduce applications does only filtering and transformations, and it does not do a lot of aggregation, and you have no reducers configured to execute your MapReduce applications. In that case, the page capacity is completely waste. Okay, because we are pre-configuring the number of mappers and reducers, so there can be a scenario where your cluster is underutilized or overutilized. For example, as you are running map-only applications, this can be under configuration. At the same time, if you are running jobs which requires a lot of reducers, then it can be over configuration for mappers and under configuration for reducers. So either your cluster might be underutilized, or your jobs can be over. Jobs might be hogged for resources. So in short, our cluster is not being used efficiently. So by pre-configuring the number of mappers and reducers, it is scalable, but at the same time it is not as efficient as it could be. Okay, that is another challenge in MRV1, where you pre-configure your mappers and reducers. And also log files are scattered across all the nodes in the cluster. So when you submit the job, the logs will be scattered on all the nodes in the cluster. Either you have to go to web UI and navigate through each and every task to go to the log details, or you have to run a crawler which will go through the logs and consolidate all the errors that are happening in your jobs, which is tedious. So these are the main challenges with MRV1, and MRV2 tries to address all these issues. Okay, so ARM stands for External Resource Negotiator. It's a generic job management tool which can share resources between MapReduce based distributed processing tools as well as non-MapReduce based distributed processing tools. So if you go back here, so HDFS will be storage, Yarn will be, it is termed as Hadoop operating system, Hadoop data operating system. And on top of that, you can configure both MapReduce based solutions and non-MapReduce based solutions. All these things can use Yarn. So Yarn can keep track of resources of everything that is running in the cluster. So it can make better judgment while submitting the jobs to execute the mappers and reducers, mapper, reducer tasks, or any other tasks related to the tool which you are trying to execute. Okay, and daemon process are resource manager and node managers. So first let me configure. So in production environment, either you use classic or Yarn. You will not use both. Okay. So due to that, I am first stopping the MapReduce. There is no point in keeping both of them up. When it is stopping, I will start clicking on add a service. And now we are talking about Yarn. You can click on that and hit continue. And I want to use HDFS and Zookeeper. And here also it is asking to customize the role assignments. I want to make 4 as the resource manager. Okay, and job history server. You will understand the significance of job history server. So as I mentioned to you, one of the challenges, the log files are all scattered. In Yarn, there is something called job history server. It will consolidate all the log files into HDFS, and you can access all the log files using one user interface rather than going through multiple nodes in the cluster. So that's where job history server comes into picture. And then node manager, leave it. So it will automatically pick wherever data nodes are running. If you want, you can make sure that it is picking up the correct ones. You have to review it before deciding it. In this case, all these nodes have data nodes, and we are configuring name nodes on these. So it is very important to review this. You should not configure name nodes or task trackers on any other nodes than where data nodes are running. Okay, so you have to review it. As it looks good, you can hit continue. And you can hit continue. Yeah, I was on mute. I'm sorry. So I'm not sure where I stopped. Okay. Okay. So we have set up the yarn, and now we will look into parameter files, and you can to get the parameter files, you can go to home and click on yarn and click on configuration, and these parameters are categorized by Cloudera. And so these are nothing but categories of all the parameters that are related to yarn service. Even whether it is HDFS or MapReduce, it follows the similar structure. All the parameters will be categorized. Service wide will be for the entire service. Gateway is for gateways. Node manager, if you want to make some changes for the slave nodes, and if the parameters are related to the slave nodes, it will be under node manager default group. Resource manager is for the master. Okay. So you can, if you know the category, you can directly go there and search for it. Otherwise, you can actually search over here. So in this case, let us see the resource manager. Where is it? Yeah, resource manager address. And it is showing only port number. It is actually not showing the IP address, even though there is IP address. All this massaging is done by Cloudera. Okay, if you want to actually see this resource manager address in answer.xml file, you can go to the resource manager's host, and then you can go to var1 Cloudera CM agent process lsltr, and then you can look at 514 yarn resource manager, and then you can look at yarn site.xml. Okay, and here resource manager.address will tell you the host name and port number. But when you see in the configuration file, it is only showing the port number. The reason is it do not want to let you change the resource manager from the from configuration perspective. If you want to change the resource manager, you have to go to the services, you have to delete the service, and you have to add the service back and make a particular node as a resource manager. Changing parameter files directly can cause issues. So that is the reason why for certain parameters, Cloudera is only showing the IP addresses, port numbers, so that you don't accidentally change the IP address and cause the issue. If you want to change anything at IP level, especially like changing the resource manager, you have to delete the service and add it back by configuring to a different IP address. At the same time, if you want to know the actual IP address, you can go to this location and look at the parameters, and this will actually show you the true picture. Cloudera Manager does some messaging behind the scenes, so it might not reflect the true picture of your parameter files. Okay, and also on mute, I have mentioned some important points. Let me recap those things. I have deleted the MapReduce service, and if you look at the Google spreadsheet, Google Sheet, even in this, I am asking you to, after you validate your map framework or classic framework, delete the MapReduce service, and then only go ahead and configure the yarn. There is no point in configuring yarn and MapReduce at the same point, and it can cause some confusion. It is not it is not mandatory to delete it, but it will be best practice to delete it. So delete the MapReduce service and then only configure the yarn. Okay, so that now coming back to parameter files, there are two parameter files, ansite.xml and maprite.xml. And if you think about MR1 Classic, we have only map.site.xml. We don't have answer.xml. So, but when it comes to Yarn, you will have one for Yarn and the other one for MapReduce parameter. So if you go back to the host, we are in the yarn site.xml file. So if you look at map.site.xml file, okay, it has only job history web address. So we will see the job history purpose in a moment. It is typical to see in most of the cases, you might see the framework related parameter also here. I'm not sure why it is not showing up here. Let me do this. Yeah, configuration. Yeah, so it picked the default value. So this parameter also should be in the mapped site. I'm not sure why it is not showing up here. Let me see. No. So yeah, I think Cloudera is managing behind the scenes when you actually configure the yarn. If you are not using Cloudera, you will see a parameter like this in map.site.xml. But in this case, it is not showing up. So in map.site.xml, it will tell you what your job history server and also what framework you are using to process the to run the jobs. In this case, the framework is Yarn. Okay, and now if you look at the yarn site.xml, you will see a bunch of parameters, and the most important one is resource manager address, and then the second one is web app address. So earlier we have used Novysync CDH 504 50030 to go to job tracker web address to get this one. We have used Novysync CDH 504 50030. Now if I use this, it will not work because I have deleted the MapReduce service. Now I have to use this one to go to the resource manager web UI. So it will look like this. We'll come back to this later, but this is how you will look like. So this is another important parameter which will tell you the web address of your resource manager web UI. Okay, and then there are plenty of other parameters which are not that important. But for admins, there are some parameters that are related to memory configuration, which I will cover in a moment. Okay, so that is about parameter files. We have two files, mapped site and yarn-site.xml, and we have seen resource manager web UI. And to see the application master web UI, you have to first you have to understand the architecture of Yarn and the difference between MR1 Classic and Yarn, and then you will understand what is the application master web UI, and then we'll talk about job history server. Okay. First, let me explain critically how the job is submitted in Yarn, and then I will show you the application master by running a job. I'm going to whiteboard. So now we have the cluster. This is our slave. And each slave have HDFS for storage and node manager for processing. Okay, and then we have master, name node for storage, and resource manager for processing. Okay, so when job is submitted, if it is earlier we spoke about the job tracker. Earlier we spoke about job tracker and task tracker. So these are the ones which use it for processing. So earlier job tracker used to submit the job, okay, and the task tracker used to translate the job into mappers and reducers, and task tracker used to submit the map tasks and reduce tasks by forking a JVM on all the slave nodes in the cluster, on as many slave nodes in the cluster to give you the distributed computing. So here, job tracker is the one which is submitting the job. So when you run the Hadoop jar command, let's take the example of client also. So let's say this is the client, our gateway node, and you run Hadoop jar command from here. Okay, using the classic framework, the request goes to job tracker, and then depending upon where the data resides, job tracker will push the jar file to those nodes, that is called as data locality, and code is going to data. So the jar file will be pushed to data nodes wherever it has to run, and there the JVMs will be forked in the form of mappers and reducers, and they will process the data. Okay, so mappers and task trackers will be actually executing the data, processing the data. Task trackers will keep track of the progress of the individual mappers and reducers, and as they keep track of progress, they also send the details to job tracker, and job tracker will aggregate the data, and it will actually display the report like this. Okay, so when we actually run the job previously using this command, what's happening is job tracker submitted the job, and task trackers. So job tracker will determine where the blocks are, and it sends request to the task trackers where the blocks are, and task tracker will actually fork mappers and reducers, and they will keep track of the progress of mappers and reducers. And as they keep track of progress, they will send that information back to the job tracker, and job tracker will aggregate that information, and it will compute how much percentage is done, and it will show you all the details as the job progresses. So here, job tracker is doing two things. First, it is keeping track of the resources in the cluster. It is submitting the job in the cluster, and also with respect to submitting the job in the cluster, it is also keeping track of the how job is progressing in the cluster. So in a very large cluster, the job tracker can become a bottleneck, because it uses lots of resources. It is resource intensive, and it has to submit the jobs. It has to keep track of the task trackers, what are running and what are not running, and also it has to keep track of resources information, and also it has to keep track of the progress of the jobs. So it is doing a lot of work, and in a very large cluster, it can be overwhelming, and it can cause health issues to job tracker, because it is doing so much of stuff. So for that reason, as part of Yarn, what they have done is, so what job tracker is doing is, it is submitting the job, keep track of resources. Second one is submit jobs, and keep track of jobs. So as part of the new architecture in Yarn, what they have done is, they have decentralized keep track of jobs from resource manager. So resource manager is a counterpart for job tracker in Yarn, and it is the master to process the data, and node manager is the slave, which will be running on all the nodes in the cluster. So resource manager will keep track of resources, and it will be used to submit the jobs, but it will not keep track of the jobs. And for that reason, they have created something called job application master. and this application master will keep track of the job progress. Resource manager will no more will keep track of the job progress. Let me see, I'm getting noise. Okay, so now let me run a job and I will explain. I think you will understand once I run the job. Okay, to run the job from the gateway node, I have to first add it as a gateway. If I run it directly, it might run in local mode, as we have seen earlier. So first we have to add gateway to 200. So I'm going on home, click on yarn, click on instances, and see there is no gateway for yarn. So we have to create a gateway. You can select all, click OK. Resource manager and node manager are already selected. Hit continue. Okay, now you have to redeploy the configuration. Why I am doing this multiple times is so that you get the logic of the purpose of gateway node and all. And these kinds of mistakes will recur, and people struggle to troubleshoot these kinds of issues. So you need to clearly understand what is the role, and definitely will be able to troubleshoot it easily. And what all is running on each of the nodes. So keep this in mind. We have seen the job tracker and we have seen only this screen. And when you click on the job, and when you try to navigate, when you click on individual tasks, it will go to different location, means different URLs, and it will get the details. But at the higher level, to monitor the job, you only go to this page, and all the jobs are pointing to this link. Whereas now I will run So first thing you need to observe is the syntax does not differ. Whether you are using yarn or MapReduce, the syntax is same. Okay, but the output. Let me copy this output somewhere, the previous one. Okay, and if you see the output directly goes to the job ID, and then it is running. Whereas here, it is giving you a link. Okay. It is giving a link, and you can use that link to check the status of the job. And now, if you see the URL, it is going to 504, which is resource manager. Actually, here it is showing as 504, which is resource manager UI. But here, yeah, when I click on this job ID, okay, I think something is messed up. Let me run it again, because it is completed. 2, and This is the resource manager UI, and now the job started running. You can refresh. It says tracking UI, which says application master. Earlier it was unassigned. Now it is assigned. And if I click on this, why it is something is wrong. Okay. Actually, application master should not run on the resource manager. It should pick up the slave nodes. I'm not sure why it is picking up. This one should actually give the, yeah. It should not show the 504. Why it is showing 504? Oh, yeah, actually, I think in the latest version they changed something. Even though the job is running, application master is running, it's 511. The URL is a little bit confusing. I will get back to this later. But the idea is, if I go back to the whiteboard, instead of running the job from the job tracker or resource manager, the job will be running from the slave nodes itself. So the reason is so that it can decentralize the work of keep tracking of the jobs. So if you have 100 jobs that are submitted in the cluster, instead of all the 100 jobs are monitored by one job tracker, resource manager will submit the job. Before submitting the job, it will create an application master in one of the nodes in the cluster. So for 100 jobs, it can create the application master on 100 different nodes, and that one will keep track of the job. So we are now decentralizing the job monitoring onto multiple nodes in the cluster. So the probability of failure of resource manager is much lesser than compared to job tracker. So that's how we can make MapReduce more stable using Yarn compared to Classic. Okay. And also you can actually configure the high availability on resource manager, which is out of the scope of this course. But if you want, you can even configure high availability on resource manager, whereas job tracker you cannot do that. Okay, so that's how we can eliminate the issue of a single point of failure by doing two. So first one, we can mitigate significantly because of the usage of application master to keep track of jobs. And second, you can even actually configure high availability to completely eliminate single point of failure. Okay, now coming to underutilization or content of users, I will cover that later. Okay, so application master web UI, I think in the earlier versions, it used to give a different UI for each application master. Now it is pointing to resource manager. I think there is some change in the design, and that's why it is showing up like this. Otherwise, you will see different links for each and every application, depending on the number of nodes in the cluster. Okay, and then the job history server. Okay, so now we go to RM home. When the jobs are running, you will get the link for your application master here on the right side under the tracking UI. But once the job is done, all the logs will be copied to HDFS, and you can click on the history server. I configured job history on 504 itself, and there you can get the details of your job. So in this case, you can click on overview and get the counters, or click on map tasks and click on individual tasks, and then click on logs to troubleshoot the issues. So everything will be copied to job tracker, and you can navigate through this. And you can even monitor it pretty easily by writing some scripts, because you have to go to only one location to crawl rather than going to multiple locations to crawl in job tracker or classic framework. Okay, so go run MapReduce jobs and try to monitor from here, and it will be pretty clear. Okay, this is about, yeah, we will take a break, just give me a minute. And regarding the log files, once you can go through web interface and you can get to the logs, and also you can actually check the parameter file, home, new page, click on yarn, click on configuration, and you can search for log.dir. And here for Node Manager logs, it is under val log Hadoop yarn. So these are actual log files which will be copied. Initially, when the job is running, the log files will be here. After that, they will be copied under. HDFS, so that you can access the log from the job history server. Okay, so to see that, you can go to cd where log lsltr, and it is Hadoop yarn. And you can see the log files. Okay, this is the gateway node. That's why it is not showing up. I can go to so here you can see the log files. Okay, and also Hadoop jars, Hadoop FS, -ls. I think somewhere under temp also it will store the log files. Yeah, temp logs. Okay. So if you want to recursively do that, you can use -ls, -r, and then you can give more. So see, for each and every job, you can see in HDFS. Whereas in Classic, you will not find the files in HDFS. The reason why they are keeping in HDFS is you need not go between the nodes. If you want to get the logs from a centralized location, you can just download from the HDFS. Whereas in Classic framework, you have to go to add the job runs on multiple nodes in the cluster, and the logs are stored locally. You have to go to each and every node and download the log files and then troubleshoot the issue. Whereas here, you can just run Hadoop FS-get command and copy the log files to your local system, and then you can troubleshoot the issue pretty easily. Okay, so the consolidation of logs is also another significant difference between Classic and yarn. Okay, so we'll take break now for 10 minutes. And then we have already done the configuration and we have seen the parameters files. We will talk about important parameters in MRV2 or yarn. I am pausing. So please. So when it comes to parameter files, we have two files. One is map.site.xml and second one is yarn.site.xml. So Yarn is the framework to monitor the resources and submit the jobs, and MapReduce is the one which will come into picture to actually execute the job in the form of map tasks and reduce tasks. So most of the parameters that are related to map tasks and reduce tasks will be there in MapReduce.xml, and at the higher level, at the server level, all the parameters at the server level or at the cluster level, all the parameters will be defined in answer.xml file. Okay. So first, if you look at the MapReduce.xml file, the most important parameter is the MapReduce framework.name when you are using Yarn, and it should reflect as Yarn, and I think it is default. Okay. And then job history server is to get the history for all the completed jobs. So all the logs will be stored in HDFS, and job history can actually read the logs from there, and you can get it from there. And even if you want to script them, you can just use job history IP address and port number and write a crawl program to crawl the logs and troubleshoot the issues. Okay. And then am.app.mapreduce.am, AM stands for application master. So there are a bunch of parameters at application master level. So if you go here and if you search for app.mapreduce.am, so there are a bunch of parameters related to application master. As I mentioned to you, in Yarn, when you submit a job, the first thing that will be created will be application master, and it will work with the node managers to understand the resources in the cluster, and then it will actually fork the mappers and reducers depending upon the load and data locality and all those things. So to create that application master, we need to specify certain values for its JVM. This one will be the physical memory requirement for application master. By default, it is 1 GB. And how many CPU cores you want to give, and all those things. So there are a bunch of parameters that are related to application master. And then map.java.ops and reduce.java.ops will determine the size of the mappers and reducer process, and then CPU vcores. Actually, there is a container and then task in Yarn. So one set of parameters are related to containers. So that map.memorymb is container, and reduce.memorymb is container for reduce. And then for task, you have map.java.ops and reduce.java.ops. And then CPU vcores are how many vcores you should give for a given map task and reduce task. Whereas in the classic, you don't have this much flexibility. You just give how many map tasks should run and how many reduce tasks should run. Here, we will not specify how many maps and how many reducers should be run at any given point in time. Based upon the memory configuration we have done, it will determine how many containers it can create depending upon the memory on each of the node managers, and depending upon the CPU vcores and memory for each process, it will determine how the capacity internally. You will not explicitly say how many mappers or how many reducers or even how many containers should be running on a node manager. It will be determined internally by the framework itself, depending upon the vcores and memory you have configured. So for example, if you have a 24 GB RAM, let me whiteboard. Yeah, let's say you have a 16 GB RAM and 16 core. Let's say, yeah, 16 core. Okay. So you will define the memories and vcores at the container level. So you will say how much memory per container and how many Okay. How is it now? Is it good? Oh, I'm not hearing any noise. Is it good now, or is it are you still hearing a lot of noise? Okay. Let me mute it. Yeah, everyone is muted. How is it now? Is it good now, or now I have unmuted myself? Is it good now, or are you still listening a lot of noise? Okay. Then let me disconnect and I will join back. So how is it now? Are you still having a lot of noise, or is it better? Okay. So what we are talking is about and how it will determine the capacity. So how many V cores or vCPUs per container? Okay. So we have 16 GB RAM. Let's say you define 2 V cores and 2 GB RAM. That means 2 GB RAM for memory and 2 V cores per container. So that means it can run 8 containers at any given point in time. Okay. Similarly, if it instead of 2, if it uses 1 GB for memory and 1 GB for V core, it can we can run 16 containers in parallel. So you need to understand these important parameters to properly configure your cluster. When you use the tools like Cloudera, it will run the algorithm behind the scenes, and if you misconfigure, it will highlight, and you can change it. It will take the default depending upon the capacity of your cluster. If you want to override it, you can override it, but if it feels that you are over-committing, then it will send you an alert. Okay? So that is how the number of containers are determined in runtime based upon the memory and V cores you give. And this Java ops and so for example, map reduce map Java ops and map reduce map memory MB are related. Memory MB is the size of container, and in that size of container, mappers and reducers will run in JVM. So the size of map reduce map Java ops should be less than map reduce map memory MB. So that much memory will be granted for the map task itself, and then for the overhead, the remaining memory will be taken by the taken for the overhead. So this one MapReduce map memory MD and MapReduce map JavaOps are related. Similarly, MapReduce reduce memory MD and MapReduce reduce JavaOps are related. So within the container, this JVM will be forked. Okay, and then this is at the cluster level or each node level. So the and all the parameters are under amsite.xml. And the first one is related to the resource manager web address and IP address and port number. I think default port number is 8032, and then web UI IP address and port number, and default port number is 8088 for resource manager, which we have seen earlier. And then minimum allocation MB. So this will be the minimum total memory of containers on each of the nodes, and this is total memory. So the value you have given here is related to value given here at each MapReduce level. So let's say you have 16 GB RAM on your computer on each of the nodes, and if you want to give 8 GB so this is related to schedulers. This is not related to. I'm sorry, I'm little confused here. So this is related to schedulers. Schedulers are again what we have seen earlier: FIFO, FAIR, and capacity. So how much memory you should minimum total memory for containers on each of the nodes. Let me go through it again. I think I'm getting confused here. I will get back to you on these ones. But these ones are primarily at YARN level, which is at either cluster level or each node level. And I will come back to these parameters once again in the next class. And these are very important parameters. And this will determine whether you have configured it properly or not. And if you do not understand it and if you do not configure it properly, then you can see performance issues. Okay. Scheduling blocks, I have already covered this: FIFO scheduler, phase scheduler, and capacity scheduler. As long as you understand the difference between FIFO scheduler and the other two, it is more than enough. Regarding the configuration, there can be additional XML files related to phase scheduler and the capacity scheduler, which you need to explore to understand it in deep and tune it properly. And I will not be covering those things as part of the course. But if you have questions, you can get back to me and I will try to answer them. So using web interface, we have already seen that. Using OS commands. So earlier, what is this? Yeah. So if you earlier we ran a few HDFS, and we see that data node is running as one of HDFS, and then we ran MapRed, and earlier we have seen task tracker. Now task tracker is not running as MapRed. Instead, it is running as YARN. And in the task tracker, you will see proc_node manager, which is the slave in the YARN architecture. Similarly, if you go to node 4, and if you do ps-fu here, you will see resource manager. And also if you run MapRed, you will see history server, because history server is related to MapReduce, even though you are using YARN. That's why this process is owned by MapRed, and you will see this only on the wherever you have configured your job history server. Job history server need not run on the same node wherever resource manager is running. You can configure some other node as well. Okay. So for example, what I'm trying to say is, if you go back to the Cloudera manager and click on home and click on YARN, and then if you click on instances, and if you click on good health, and you can say add all instances, job history. you can actually stop this. So I'm trying to move job history to a different node. So click on close and then click on stop, delete. Okay, we cannot delete it. Okay, now if I click on add role instances, yeah, now I can change job history to a different server, let's say 5, and you can hit continue. Okay, now you can click on stop, and so it is very easy to change the services and all those things. So just understand, practice as much as you can, make the mistakes and learn. Then only we'll be able to get the complete flow and architecture to your mind. Okay. And then because it's there's a change in the job history server, your configuration files have to be changed accordingly. That's why it has complained about stale configuration. And when I click on deploy configuration, now instead of 504, we are changing into 505, and we can click on restart cluster, and you can make the it will be deployed properly on all the nodes in the cluster. And then we have to restart the Garn service. Okay. So using Cloudera Manager, we have seen how to manage this, and then verifying logs also already done. And we have seen how to validate using OS commands as well. Okay, and we have seen this as well. We have seen this also. Now we will understand more in detail about parameters, how to play with them at runtime. And also there is a important concept called counters. What is the significance of it, and how it can help you in determining whether the job is running or not. So I will be doing a demo and explaining all these things in detail. So for now we have completed configuring yarn. So I'm stopping it, and then